I'm going to be testing whether somebody could send a message on a softball wrapped in aluminum foil, which would make it non-combustible, via cannon with roughly 1 pound of gunpowder about 100 feet, getting from my property to my neighbor's property. So I added this plywood to my cannon to add stability when it's being launched, because otherwise, without the plywood, it would just go flying backwards because of Newton's third law of motion. For every action, there's an equal and opposite reaction. So I wrapped these steel enforcers around the cannon and drilled them down onto the plywood to add stability. I added a back to it. So this is my experiment setup. I'm going to have this camera filming from in here, and I got this slide out because it's pitch black and we need a lot of light for the high speed. I think we're going to have to only go with 210 frames per second, which is not the fastest. I've got my high speed camera right here. I'll probably set it to 210. Gunpowder, which I will have to pack into the cannon. Otherwise, not enough force will be exerted on the softball, forcing it upwards. I'm going to have my meter stick right here on the cannon to calculate velocity. And last but not least, my fuse, which I will stick into this hole that I drilled. And best case scenario, I light it, run inside, and cannon blows right over to the cold sauce.
Oh gosh.
Not gonna work, trust me. 0 chance.
That's gonna be cooler than the explosion. Oh, jeez.
Yes, Kevin.
Examining the video, we need to look for the point when the ball comes out of the cannon. And that is can't really tell, but it's exactly at 26.3 right there. Call 11 26.3. And then the point where it crosses the meter stick is at the end there is 27.33. So we subtract that and we get 1.03. 1.03 divided by the frames per second, which is 210, equals that times 60 seconds equals 0.29 roughly. Take that, divided by 1 meter for every 0.29 seconds equals roughly 3.4 meters per second.
Yes, Kevin.